Yes, welcome. Let's look at this JAMB past questions physics 2018 question number 9. A narrow beam of white light can be split up into different colors by a glass prism. The correct explanation is that A. White light is an electromagnetic wave. B. The prism has all the colors of the white light. C. Different colors of white light travel with different speeds in glass. D. White light has undergone total internal reflection in the prism. So what is the answer to this problem? Now, for you to understand it, you need to understand some technical terms or phenomenon in white light. And here we're talking about dispersion of white light. What is dispersion of white light? We need to know what dispersion is. For us to understand this, we need to know what refraction, diffraction, internal reflection, all those things. So, but the phenomena that goes with this very particular case is that it's what we call dispersion. So we say that a narrow beam of light, what happens to a narrow beam of white light? Can you tell me what that happened? It can actually be split up. A narrow beam of white light can be split up into different colors. You can do that. And that follows from what we have up here by a glass prism. So if you want to split up a narrow beam of white light, you use what we call glass prism. So why does this happen? This is because, and this will give us the answer to what we are asking. Why does a narrow beam of white light split up when passed through a glass prism? It is because different colors of white light. That means in white light there are actually different colors inside it. Different colors of white light travel. These different colors of white light, they move. You will not see them until you pass the white light through a glass prism. They are actually different. There are actually different colors inside the white light, and they move with different speed. So whenever you pass them through a glass prism, you will not see that some of them moving. You will not see that they actually move in different speed, and you will be able to know that there are actually different colors. And of course, whenever something is moving with different speed, you can say it is moving with varying, that is also different wavelengths. So you will not notice this until you pass it through a glass prism. Different wavelengths in a gas prism, in a glass prism. So they actually move in a different wavelength. So you'll be able now to see the different colors in the white light. This effect is known as dispersion of white light. This very thing I just explained is known as what we call dispersion. Dispersion of white light. So whenever you're asked what is dispersion of white light, dispersion of white light is actually what happens when a narrow beam of light is split up into different colors because of its passage through a glass prism. And this happens because the different colors in this very white light travel with different speed and of course varying wavelengths. So you can see that the answer from the options is just option C, because here it is written that different colors of white light travel with different speeds in glass. So that is the answer to this, and it is known as dispersion of white light. Dispersion of white light. Thank you. Hello, welcome. Let's look at this question number 10 for JAMB Past Questions Physics 2018. Figure 2, this very figure here, represents a block and tackle pulley system on which an effort of W newtons supports a load of 120 newtons. if the efficiency of the machine is 40%, then the value of W is A, 28 newtons, B, 48 newtons, C, 288 newtons, D, 50 newtons. So what is the value of the W? This is the W here. So having this is the W from the question, this is the W and this is the load. So this is L. L is equal to 120. So take note of this. L is equal to 120. This is W, which is the effort. So this is the load, L, and it is equal to 120. Effort is W, and you are needed to find out L. Also note from this that we have how many pulley system? We have 1, 2, 3, 4, 5, 6. So we have 6. So that means that the VR is equal to 6. So take note of these very things before we start the calculation. So from what is given, we have E to be equal to W, which is the effort. This is the effort. E equal to W, and that is what we are told to calculate. We have L, which is load. Load is equal to L, which is equal to 120 Newton is given. So E is equal to effort. We are supposed to know all this. This is basic things in calculations as this. Now, another thing that is given is VR, which we all call velocity ratio. VR, velocity ratio. I want to give us the formula before I start solving. How do you get this? By the number of wheels. Number of wheels. And I just counted the wheels. I have 1, 2, 3, 4, 5, 6. So VR is equal to 6. Now, having all this, we can now put the formula for efficiency, because efficiency is given us here as 40%. So efficiency, we all know in this calculation, is MA all over VR times 100 over 1. So that is what efficiency is. And we all know that MA, mechanical accuracy, is actually equal to load over effort. So with this, we can do this calculation effectively. So having known all this formula, we can now calculate efficiency again. Efficiency is actually equal to MA. MA is L over E. And L is 120 from here. L is 120 here, all over E. So in place of MA, I'm putting L over E. And you all know that E, okay, so L over E. So this is L over E. Then this all over VR. This is efficiency is equal to MA over VR. And MA is already L over E, which is 120 over E. So what is remaining is VR. So all this all over VR, which is 6. We know that VR is equal to 6. So times 100 over 1. So that is it. And we know that efficiency already is equal to 40%. So we can put 40 equal to 40. So what is left for us to make W is to make E the subject of the formula, which is the effort. And we know that E is the same thing as W. So we now have, in essence, 40, which is this 40, is equal to 120 over W. In place of E, now we are putting W because it told us that E is equal to W. The effort is W newtons. So all this all over 6 times 100 over 1. So if you do this calculation by making W the subject of the formula, you get the answer. So if we make W the subject, we have W to be equal to, and cancel out, we have W to be equal to 50 newtons. So W will give us 50 newtons. So the answer is D. W equal to 50 newtons. So how do we make this the subject? We have 40 is equal to 120 over W divided by, so you can say times 1 over 6 because it's divided by 6 times 100 over 1. So if you multiply out, you have 40 is equal to 120 times 100. You You have 1,200. Yes. This is 120 times 100. We have 12,000 all over W times 6, which is W6. So when you cross multiply, you have 6 times 40, 40 times 6 times W is equal to 12,000. So make W the subject, have W all over 12,000 all over 40 times 6. So if you cancel out, you get 50. So how do you cancel out? 0 here cancels 0. You have 4 here cancel 12, which will give us 3. So you have 300. So you have 300, 13 to 6 is 5 to 0, 0. So we have 50. So that's how we come about 50 newtons. So the correct answer is D, 50 newtons. Please note the formulas that efficiency is equal to mechanical accuracy over velocity ratio times 100 over 1. This is the formula that we use for this calculation. EFF, efficiency equal to MA over VR times 100 over 1. Now, also note that mechanical accuracy MA is equal to L over E, load over effort. This is the load here, and this is the effort that you're making to carry this load. MA equal to load over effort. Now, note that VR is the same thing as the number of wheels in this pulley system. So these are the formulas in calculating a pulley system. Efficiency is equal to mechanical ratio over velocity ratio, mechanical accuracy over velocity ratio times 100 over 1. Mechanical accuracy is equal to load over effort. And velocity ratio VR is the same as the number of the pulley wheels in the pulley system. So take note. Thank you. God bless you. Welcome. Let's look at this question number 11 for JAMB Past Questions Physics 2018. The question goes, what type of reaction is represented by the following scheme? We have nuclear X, superscript 2, subscript 1, plus nucleus Y, superscript 2, subscript 1, to form nucleus Z with superscript 3, subscript 2, plus a neutron, superscript 1, subscript 0, plus energy. The options are A, fission reaction, B, fission reaction, C, chain reaction, D, radioactive decay. So how do we go about solving this? Now, for us to be able to handle this well, we have to note that there are 2 types of radioactivity, or 2 types of radioactive reaction. And those 2 types are, 1, we have what we call nuclear fission, and number 2, we have what we call nuclear fusion. See the 2 names, fission and fusion. So whenever you hear nuclear fission, we're talking about the splitting, breakup, splitting up of one heavy nucleus. So when you have one heavy nucleus breaking up to form lighter ones, to form a lighter, or to form lighter nucleus, 2 lighter nucleus, maybe of equal parts, or you can say it is also the splitting into 2 approximately equal parts, or 2 approximately equal nucleus. And this breaking is actually with the release of huge amounts of energy. With the release of huge amounts of energy and neutrons. So when this happens, we say that we have nuclear fission. Whenever you have a big nucleus splitting together into smaller ones with the release of energy, we call it nuclear fission. But nuclear fusion is the fusing together, the coming together of lighter nuclei. So when you have two light nuclei coming together, that's smaller nuclei, we call it nuclear fusion. So when they are coming together, we call it fusion. When they are breaking up, we call it fission. So when smaller ones come together to form a heavier nucleus, we call it nuclear fusion. And this also happens with the release of energy. So whenever there is radioactivity, there is always release of great amounts of energy. So this happens with the release of large amounts of energy. Very, very important. So we have nuclear fission or nuclear fusion. So here, when you see fusion reaction, it also simply means nuclear fission. And when you see fission reaction, it means nuclear fission. So which of these explains this? You will see that when you look at this nuclei, this is 2 and here is 2. But they form 3. So you have smaller ones coming together to form big one with energy. Here is 1 and here is 1 and here we have 2. So we have this and this combining to form this. So you can say that this is actually nuclear fusion because they are coming together to form a bigger one. So anytime you want to study this, please, you have to take note of you look at the nucleus that you have on the other side, on the reactant side. If they are smaller, like the case we have here, these ones are smaller. We have 2 and we have 2, but here we have 3. So we have smaller ones forming bigger one with release of energy. So we call it nuclear fusion. And that's why option A is the right answer. If they are breaking down, had it been this one having like 1 or half, is lesser, then it will be fission. But when they are coming together to form a bigger something with the release of energy, we call it nuclear fusion. So nuclear fusion, or you call it fusion reaction, that is the answer. Thank you. Look at this question number 12 for JAMB Past Question Physics 2018. The amount of heat needed to raise the temperature of 10 kilograms of copper by 1 Kelvin is its A, specific heat capacity, B, latent heat, C, heat capacity, D, internal energy. Now, for us to be able to appreciate this question very well, we need to know the definition of these various terms. And we're going to start with number 1, which is specific heat capacity. Now, whenever you hear the word specific, you're considering 1 kilogram. Here we have 10 kilograms. And even we have 1 kilogram. You know we are talking about specific heat. So this definition still holds true for specific heat, but in this case we're having 1 kg. So specific heat capacity is the amount of heat needed to raise the temperature of 1 kg, it has to be 1 kg, of a substance. This time around we have copper, but it could be any substance or any metal, by 1 Kelvin. So that is what specific heat capacity is. Now number 2, we look at latent heat. What is latent heat? Latent heat is that amount of heat needed, the amount of heat needed to cause change in state. The amount of heat needed to cause change in state. That is when there is change from solid to liquid or liquid to gas without rise in temperature, without rise in temperature. So when latent heat is used, there is no rise in temperature. Now number 3, we look at heat capacity. What is heat capacity? Heat capacity is the amount of heat needed to raise the temperature, of a given mass. So this is a given mass, 10 kg, it could be 20, it could be 30. So provided the mass is not 1 kg, then we'll call it a given mass of a substance by 1 Kelvin. So that is what heat capacity is. Whereas internal energy is the energy due to the molecular bonding. So internal energy is the energy due to the molecular bonding. So the molecular energy, the positioning of the molecules, that is what causes the internal energy. So from these definitions, we can see that C is the right option, because heat capacity is the amount of heat needed to raise the temperature of a given mass, say 10 kg, it could be 20, it could be 30, it could be 100 of copper by 1 Kelvin. But if this mass is 1 kg, then it will be specific heat. So whenever you hear the word specific, we're talking about 1 kg. But once it's more than 1 kg, we'll talk about heat capacity. And that is the answer to the problem. Option C. Thank you. Now let's look at this question number 13 for JAMB Past Questions Physics 2018. The electrochemical equivalent of silver is 0.0012 gram per coulomb. If 36.0 gram of silver is to be deposited by electrolysis on a surface by passing a steady current for 5 minutes, the current must be A. 600 amperes, B. 100 amperes, C. 10 amperes, D. 1 amperes. This should be in capital letter amp. The A's are in capital letter for amperes. Now, let us solve this. First of all, for us to be able to solve this, we need to recognize the fact that the electrochemical equivalent of a substance is the amount of the substance mostly in mass deposited by 1 coulomb of electricity in an electrolytic process. So that very amount is actually represented with the letter Z. Now, the relationship between mass deposited and the quantity of electricity is Q times Z, which is the electrochemical equivalent. And we know that Q is equal to current times time, IT. So we can now say that mass deposited is equal to current times time times Z. So with this, we can make current the subject of the formula I. Making it the subject, we'll have M all over Tz. So that is what we are going to be doing to calculate the current. So the current is equal to mass. Mass as we have here is 36 gram, 36 all over T. T is the time. We have T here as 5 minutes. We need to convert it to seconds, so it's going to be 5 times 60. So times Z, which is the electrochemical equivalent, which is 0.0012, 0.0012. So if we solve down, if we press our calculator to solve down, we are going to find out that we have 100 amperes. And that is the final answer, B. And this is the B, 100 amperes. This is A. This is 6,000 amperes. This is 10 amperes. The A is in capital letter. So the right option is 100 amperes because when you cancel out, 6 here is going to give us 6. Here is going to give us 10. So if you cancel out, you're going to have 100 amperes. And that is the answer to this problem. Thank you. Welcome. Let's look at this JAMB past questions, physics 2018, question number 14. Shadows and eclipses result from the A. Refraction of light, B. Reflection of light, C. Diffraction of light, D. Rectilinear propagation of light. So which of the following causes the shadows and eclipses? What causes the shadows and eclipses? Is it the refraction of light? Is it reflection of light? Or is it diffraction or rectilinear propagation of light? Now, the right option is rectilinear propagation of light because all these are caused by the movement of light in a straight path. So whenever you have your light and it moves in a straight path, if something is blocking it, you have what we call shadows and eclipse. And you know that eclipse happens when the sun is at the middle, then with the earth revolving around it, and also the moon revolving around the earth. So whenever the moon is in between the earth, this is the earth and the sun, you have what we call eclipse, which is a special kind of shadow that is being cast on the earth because of the blocking caused by the moon. And this is actually because the sun is emitting light that is traveling in a straight line. And motion of light in a straight line is known as rectilinear propagation of light. So whenever you hear the word rectilinear, it simply means movement of light in a straight line. Movement of light in a straight line. And that is why option D is the correct option. So rectilinear propagation of light is the movement of light rays in a straight line. That is what rectilinear propagation. And this rectilinear propagation of light causes so many things, not just the shadows and the eclipse. It is the cause of, number one, shadows. Shadows are caused by rectilinear movement of light in a straight line. Number two, eclipses. Eclipses is as a result of this. Then you also have application like the pinhole camera. If you know about the pinhole camera that you use in physics, it is also due to the rectilinear propagation of light. And finally, we have what we call the ray box. The ray box. All these are possible because of the movement of light in a straight line, which is known as rectilinear propagation of light. So, refraction is another property of light, reflection and diffraction. But this and when you talk about reflection, you're talking about when you have a plane mirror and you have the incident ray, then you have the reflected ray. Then when you talk about refraction, you talk about when you have a prism, then you have light coming here. Then instead of being reflected, it goes in here and comes out like this. This is the refraction. So we have refraction of light. All these are different motions of light. This is reflection. So these are different motions of light, but the ones that are responsible for the very movement of light that is responsible for shadows, eclipses, pinhole camera effect, and the ray box effect is the movement of light in a straight line, which is also known as rectilinear propagation of light. Thank you. Come, let's look at this JAMB past question physics 2018, question number 15. Which of the following obeys Ohm's law? Option number A, all metals. B, diode only. C, all electrolytes. D, glass. Now, we should always know that whenever you talk about Ohm's law, it has to do with metals. And what is the statement of this Ohm's law? In order for us to get this well, we need to note the statement of this Ohm's law. And what does it state? Ohm's law states that the current passing through a metallic, you see why I say it has to do with metals, passing through a metallic conductor. So Ohm's law has to do with metals. So the current passing through a metallic conductor is directly proportional to the potential difference across its ends. That is the statement of Ohm's law, that the current passing through the metallic conductor is directly proportional to the potential difference across its end. And this law holds true provided that that is for the conductor, its physical components and temperature remains constant. So that is the statement of Ohm's law. In equation form, you can say that the potential difference is directly proportional to the current. And when you remove the proportionality sign, you now put equal to, you introduce a constant, and that constant is known as resistance. So this is the statement of the Ohm's law, that potential difference is directly proportional to current. And when you remove the proportionality sign, you introduce the equal to and introduce a constant. The constant of proportionality here is known as resistance. And you can use this equation to calculate the current, resistance, or potential difference for a conductor. So from the statement of the Ohm's law, which I just stated now, you can see that the Ohm's law has to do with metallic conductors, metals. So from the options, you can see that the most likely is option A, which is all metals. Though I also think that some metals don't actually obey Ohm's law like that, like tungsten that is used for bulb. So the right option here is A, all metals, because in the statement of Ohm's law, we have that Ohm's law states that the current passing through a metallic conductor is directly, whenever you say directly, this is the sign, directly proportional to the potential difference V, provided that the temperature remains constant. And that is that. Thank you. This question number 16 for JAMB Past Question Physics 2018. And the question goes like this. Which of the following statements are true of isotopes? I. Isotopes of an element have the same chemical properties because they have the same number of electrons. II. Isotopes of elements are normally separated using physical properties. III. Isotopes of an element have the same number of protons in their nuclei. The options are A, I and II only, B, I and III, C, II and III only, D, I and III. So which is the correct option? Now, for us to be able to appreciate this question very well, we need to know what isotopes are. So what are isotopes? And we know that isotopes are or is actually an existence. That's what isotope is. The existence of atoms. It's a phenomenon where atoms exist. And those atoms are of the same existence of atoms of the same atomic number. Atoms of the same atomic number. And whenever you hear the number, atomic number, it simply means the number of protons. Atomic number simply means proton number is the same. So when there is this existence of atoms of the same atomic number and the same properties, the only difference between this atom is actually that they differ in their mass numbers. So when you have atoms of the same atomic number but different mass numbers, then you know that the phenomenon known as isotopy is happening. So isotopy is a phenomenon whereby atoms exist in the same atomic number but having different mass number. And whenever you talk about mass number, you are talking about the number of protons, that's the proton number plus the neutron number. So proton number plus neutron number, that is what mass number is. So if you have an atom that has, let's say, 9 protons, 2 of them having 9 protons, but because one is having 10 electrons and the other one is having 12 protons, this one is going to have mass number of 19 and this one is going to have mass number of 20. So you see that their proton number is the same but their neutron number is different. So that is what we call isotopy. And how you notice that the proton number is different is that their mass numbers are going to be different, because mass number is proton number plus neutron number. And note that proton number is always equal to electron number. Why? Because the atom is electrically neutral. So from this we can easily pick out the answer, because I says isotopes of an element have the same chemical properties because they have the same number of electrons. Yeah, because their proton number, like I said, the proton number is equal to electron number. That means they have the same number of isotopes have the same number of electrons. So I is correct. Now, isotopes of elements are normally separated using physical properties. We don't know of this fact, so this cannot be true here. But the you have isotopes of an element have the same number of protons. That is what I said here. So this is also correct in their nuclei. So we have option I and III to be correct. So this B is the right option because I is correct and III is correct. So we are very sure about these two. We are very sure about I for isotopy, and we're also sure about II for isotopy. So if we use elimination method, we can easily pick option B as the right option for this, because isotopes isotope are existence, or you can say isotopy is the existence of atoms of the same atomic number, that is proton number, and properties. They have similar properties because of this similar proton number, but they only differ in their mass numbers. They differ greatly in their mass numbers. So that is the answer for this. Thank you. Let's look at this JAMB past question. Question number 17 for Physics 2018. In the diagram above, the hanging mass M2, this is the hanging mass M2, is adjusted until M1 is on the verge of sliding. The coefficient of static friction between the mass M1 and the table is option A, M1 over M2, B, N1G over M2, C, M2 over M1, D, M2G over M1. So how do we go about solving this? Question number 17. Now, in order to be able to appreciate this question, we need to understand what coefficient of static friction is. And coefficient of static friction is actually the frictional force F all over the normal force R. So that is what coefficient of static friction is. Then basically, looking at this diagram and looking at the options that we have here, you can simply relate this by saying that U is the force by this M2, which is mass times acceleration due to gravity, all over the force by this M1, also times this acceleration due to gravity. So if you cancel this D and G, you will have U to be equal to M2 over M1. And that is C as being the option and the correct answer for this. So C is the answer. Thank you. Let's look at this question number 18 for JAMB past question physics 2018. Which of the following may be used to explain a mirage? I. Layers of air near the road surface have varying refractive indices in hot weather. II. Road surfaces sometimes become good reflectors in hot weather. III. Light from the sky can be reflected upwards after coming close to the road surface. So we have the following options: A, I and III only, B, II and III only, C, II only, D, I, II and III. Now, for us to be able to understand this concept very well, we need to know what a mirage is. So how do you explain the concept of mirage? Now you are driving your motor on the road on a sunny day. So you're moving on the road on a sunny day. Then you sitting inside your car, you look down you're going to be seeing something that looks like a pool of water. But as you're driving closer to that pool of water, you see that it disappears and you find it another place. So this very phenomenon is known as mirage. So if you drive a car often, you find out that you've noticed this once or twice in your lifetime, or as several times as possible. So when you're driving, you see something that looks like a pool of water, and it's not as if it does exist, but it's actually because of the hotness of the weather, because of the reflection of the light rays from the sun. So now, taking this in perspective with what the question is, so what are the options that are likely answers? Now, layers of air near the road surface have very varying refractive indices in hot weather. That is true. So I is true. Now, road surface sometimes become more reflectors in hot water. Does something become more reflector after some times and doesn't become in some other times? You see that this I is shaky. But this number three thing, lights from the sky can be reflected upwards after coming close to the road surface. That is reflection, and that is true. So you can easily see that I and I are very true. So with that, I can pick option B as the correct answer. Thank you. Let's look at this question number 19 for JAMB Past Question Physics 2018. In the diagram above, this is the diagram. If the atmospheric or the atmosphere pressure is 760 millimeter, the pressure in the chamber G, this is chamber G, is A, 660 millimeters, B, 830 millimeters, C, 690 millimeters, D, 860 millimeters. So how do we go about solving this? There is this general formula that whenever we have a tube of this kind with a chamber, that the right way to do our calculation is that the pressure that this distance is making plus this distance will give us the pressure that this other distance is making plus the distance. So with that, we can say that if we are considering this as pressure 1, this height as pressure 1, we have pressure 1 plus the distance as D1. It will give us what this one is making, pressure 2 plus the distance D2. So with that said, the pressure 1, like we are giving here, is the atmospheric pressure, which is 760 millimeters plus D1, as we can see here, is 10. And this 10, if we convert it to millimeter, is going to give us 100 millimeters. So we have 100 millimeter here equal to P2. P2 is what we are looking for, plus D2 is 3. If we convert this to millimeter, we have 30. So this 760 plus 100 is going to give us 860 to be equal to P plus 30. So making P the subject, P is equal to 860 minus 30, which will give us 830 millimeters. And that makes B the correct answer to this using this simple formula. So check it out. And that is how you can come around the answer. Thank you. Look at this question number 20 for JAMB Past Question Physics 2018. Which of the following has the lowest internal resistance when new? A. Leclerc cell. B. Daniel cell. C. Touch battery. D. Accumulator. Now, for us to be able to appreciate this question very well, we need to know, first of all, note what internal resistance is. Whenever you're talking about the batteries or cells, we talk about internal resistance, small letter R, as against the normal resistance, big letter R. So what is internal resistance? We know that internal resistance is the opposition. That is what it is. The opposition given to a voltage source. That opposition that is given to a voltage source is the internal resistance. Now, in order for you to be able to pick out the internal resistance, you're going to ask yourself which of these cells or which of these batteries or these charge sources produce the highest charge. You find out that that is likely to be the one that has the least internal resistance. And from there, you know that the accumulator is the charge source that produces very high voltage for a very long time. So it's most likely going to be the one that has the least internal resistance. Because Rectilinear cell and tunnel cells, they are smaller versions of battery cells, even touch battery. But the accumulator, we know, can be used in, this is what you use in big automobiles and in houses. So D is the correct answer for this. Thank you. Let's look at this question number 21 for JAMB Past Question Physics 2008. The pitch of an acoustic device can be increased by A. Decreasing the loudness, B. Increasing the amplitude, C. Increasing the frequency, D. Decreasing the intensity. Now, for us to be able to appreciate this very well, we need to first of all know what a pitch is. But as a point of note, whenever you hear the word pitch, know that it has to do with frequency. Anytime in sound that you hear about pitch, know that it has to do with frequency. Now, what is the pitch of a given sound? We can say that the pitch of any given sound is the location of a musical note on a musical scale which can be determined by frequencies, which can be determined by frequencies of the sound made. So when you want to get a pitch of a sound, it has to be located by taking note of the location of the musical notes in a musical scale. And this musical scale is actually determined by the frequencies. So when you're talking about increasing the frequency, increasing the pitch, you are talking about increasing the frequency, and that makes option C to be the right answer. So whenever you have questions relating pitch, know that you are talking about frequency of sound, and if you want to increase the pitch, you have to increase the frequency, and that is the answer to the problem. Thank you. Let's look at this question number 22 for JAMB Past Questions Physics 2018. One of the features of the fission process is that A. It leads to chain reaction, B. Its products are not radioactive, C. neutrons are not released. D. The sum of the masses of the reactants equals the sum of the masses of the products. Now, for us to be able to appreciate this very well, we need to note that in a nuclear fission, we talk about a nuclei of an atom disintegrating into smaller ones. So we have this big one, let's say having 10 and 2, disintegrating into the ones that have 3, 4, 1, 1, with the release of neutron and energy. So this is what we call a fission reaction. Once you have the atomic number and the mass number here bigger than the ones here, we call it fission. But in a case where we have these smaller ones by this side coming together to form the bigger one by this side, we call it fusion. These are the two types of radioactivity that we have. We have nuclear fission and we have nuclear fusion. So when it's fission, we're talking about the big one splitting into smaller ones. But when the smaller ones come together to form the big one, we call it fusion. So how do you know the smaller one and the big one? By checking their atomic number and mass number. So the right-hand side here is bigger than this side. So this is fission, whereas this is fusion. Now, so let's look at this question again. One of the features of fission reaction is that A, it leads to chain reaction. Most of radioactivity reaction leads to chain reaction. So this is a correct option for now until we check all these. Its products are not radioactive. That is not true. Some of the products of radioactivity can also disintegrate more to form even smaller ones. So the product can be radioactive. So this is not true. Neutrons are not released. Neutrons are actually released. So this cannot be true. Now, the sum of the masses of the reactants equals the sum of the masses of the products. The sum of the masses here is not exactly equal to this because there is the release of other particles like neutrons and there is the formation of energy. So this is not true. It cannot be equal. So from this elimination method, we'll find out that A is the correct answer to this because, like I said, radioactivity leads to chain reaction. And that is the answer for that. And the two types of radioactivity is fission and fusion. And I say that fission process is when there is splitting up to produce smaller ones, whereas fusion is when there is coming together of smaller ones to form bigger ones. Thank you. Let's look at these JAMB questions for Physics 2018. Question number 23. The linear expansivity of brass is 2 times 10 to the power minus 5 bar. C, which is Celsius. If the volume of the piece of brass is 15.00 cm cubed at 0 degrees Celsius, what is the volume at 100 degrees Celsius? A, 16.03 cm cubed, B, 15.09 cm cubed, C, 16.00 cm cubed, D, 15.03 cm cubed. Now, for us to be able to appreciate this question, we need to know what linear expansivity formula states or what cubic expansivity. Now, whenever you're talking about volumes of expansion, we are talking about cubic expansivity or volume expansivity. And what is this expansivity in terms of volume? It is actually change in volume, which is the final volume minus the initial volume, all over final volume over the initial volume is V1, final volume is V2, all over V1 times change in temperature. Now, volume expansivity You call it cubic or call it volume expansivity. So you can call it any of these. Now this volume expansivity is also equal to 3 times the linear expansivity. So in case if you are not given the value of your volume expansivity, you can get it by the linear expansivity value that you are given by simply multiplying it by 3. So once you multiply the linear expansivity by 3, you should be able to get the volume expansivity. So we are given the linear expansivity. So we say 3 times the linear expansivity gives us the volume expansivity, and is equal to the final volume minus the initial volume all over the initial volume times change in temperature. So with that, we can simply solve this because all these are already given. So the linear expansivity is already given as this. So I can say that this is equal to 3 times linear expansivity, which is 2 times 10 to the power minus 5, equal to the final volume, which is what we are looking for, we don't have it, minus the initial volume, which we are given as 15 cm cube. So I'm going to write 15 here, all over the initial volume, which is also 15, times change in temperature. Change in temperature is, we have 100 minus 0, which is also 100. So the change in temperature here is 100 minus 0. So if you solve out and make V the subject of the formula, you are going to find out that V2 is going to be equal to 15.09. So that is the answer to this. So B is the correct option. So how can we solve this down to get this? So having this can give us 6 times 10 to the power minus 5. That is 3 times 2 times 10 to the power minus 5 gives us this, equal to V2 minus 15 all over 100 minus 0 is 100. 100 times 15 is 1,500. So when you cross multiply, you're going to have V2 minus 15 is equal to 6 times 10 to the power minus 5 times 1,500. That is 1,500. So if you multiply this out, and you make V the subject. So we're going to have V2 is equal to 6 times 10 to the power minus 5 times 1500. All these plus 15. That is when this 15 goes to this side. So if you multiply this out and add it up to this, you will be able to get 15.09. Because this times this is going to give us 0.9. So plus 15 is going to give us 15 plus 0.09. And that is the correct answer to this. Thank you. Welcome. Let's look at this JAMB past question physics 2018, question number 23. A lead bullet of mass 0.05 kilogram is fired with a velocity of 200 meters per second into a lead block of mass 0.95 kilogram. Given that the lead block can move freely, the final kinetic energy after impact is A. 150 joules, B. 100 joules, C. 50 joules, D. 200 joules. Now, for us to be able to appreciate this question very well, we need to understand the formula of conservation of energy and momentum when there is an impact due to firing. Now, whenever you hear impact due to firing, you're going to be able to note that you'll be having the initial mass of these lead bullets multiplied by its velocity plus the mass of this block onto which it is making impact, M2, multiplied by the velocity before the impact. Now, after there is an impact, you're not going to have the two masses m1 plus m2. Now the masses are together, they are now moving with one single velocity v. So this is the right expression to solve this. This is the bullet and this is the block. So this bullet goes into this block to form a bullet and a block together, moving now. So this is moving, making this impact to form this. So this is what equation that we have. And from this equation, we can calculate this final velocity. With this final velocity, we can now calculate the final kinetic energy to be equal to half mv squared. So this final velocity, we need it to do this calculation. We know these initial velocities and masses, but we don't know this final velocity. So that is what we need to calculate. Once we calculate it, we can put it in this formula for kinetic energy to find out our kinetic energy. And that is what we're going to be doing. So make this V the subject of the formula. We have V to be equal to everything here. We have M1 U1 plus M2 U2 all over M1 plus M2. So that is V. So with that, we can say that our V is equal to M1 is what? 0.05 times U1 is what? 200. We are given initial mass is 0.05. This is the initial velocity for that. Then plus M2 is what? 0.09. This is our M2 here. 0.09 times this bullet went into this block. This block was not moving initially, so the U2 is 0. So all over M1 plus M2, M1 is what? 0.05 plus M2 0.09. I mean 0.95. So if we solve this out, we are going to be getting 10. That's what we'll get, because this times this, this will go 1, 2 to cancel these 2. So that we have 2 times 5, which is 10, plus this times 0 will give us 0. So we have 0 here all over. 0.05 plus 0.95 is 1. So you have 10 plus 0, which is what? 10 over 1, which is 10. So V is equal to 10. From this calculation, our V is equal to 10 meter per second. So having V as 10 meter per second, we can now calculate KE, which is kinetic energy, which is giving us half M. The M is the mass, the total mass, which is 0.05 plus 0.95, half M times V squared, and V is what? 10 to power 2. So V is 10, so square is 2. So here we have 0.05 plus 0.95, which is 1. So 1 is what we are going to do. So we are still going to have half times 1. So we have half times 1 times 10 to power 2. And 10 to power 2 is what? 100. So we simply have this is equal to 100 all over 2. Because 1 times 1 is 1. 1 times 10 to power 2, 100. So this is 100 over 2, giving us the final answer as 50 joules. And C is the right option for this, which is 50 joules. So you can see how we came about this by quoting this initial formula for impact. Whenever there is collision, and we have one thing colliding with the other, with their initial velocities and their masses, to form this final velocity when they are now together. So if you make this V the subject of the formula, you get, using the values we have, noting that the velocity of the second, the lead block is 0 because it's not moving, we'll get V as 10. So if we put it in this equation for kinetic energy, which is half mv squared, we'll get kinetic energy as 50 joules, which is the answer. Thank you. Let's look at this JAMB past question physics 2018. Question number 25. In a series RLC circuit at resonance, the voltages across the resistor and the inductor are 30 volts and 40 volts respectively. What is the voltage across the capacitor? Option A, 30 volts, B, 70 volts, C, 50 volts, D, 40 volts. Now, for us to be able to appreciate this effectively, we need to know what resonance is, so that we will know what resonance in a series RLC circuit is. What is the significance of resonance in a series RLC circuit? Now, we can confidently say that resonance occurs in a series circuit when the supply frequency, whenever the supply frequency causes the voltages across L and C, that is inductance and capacitance, to be equal and opposite in phase. So whenever the voltage across the inductance, this is known as the inductance L, whenever the voltage across the inductance and the capacitance, or the inductor and the capacitor, is equal, we call it resonance. That is happening in a series circuit, and this is a series RLC circuit. So for there to be resonance, since we are saying that resonance is happening, it simply means that the voltage in the inductor, this is the inductor, the voltage here is 40, is the same as that of the voltage of the capacitor. So the voltage of the capacitor is supposed to be 40 as well. So D is the right option as the answer. So whenever there is resonance, whenever there is this phenomenon called resonance, that means that the voltage across the capacitor and that across the inductor should be the same. They should be equal. So since the voltage on the inductor is 40, that of the capacitor is also 40. So that makes D the correct answer. So this is the kind of circuit that we're talking about. You have the capacitor, it's in series with the resistor, and this is the capacitor, this is the resistor, this is the inductor. So the voltage in the inductor, if it is V1, then the voltage in the capacitor is going to be V1 too. So in this case, we say that there is what? Resonance. So resonance occurs when the supply frequency causes the voltage across both the inductor and the capacitor to be equal. And in this case, it is 40, and that is the answer. Then at resonance, we have what we call minimum impedance. It's also good that you note that at resonance, we have minimum impedance. Minimum impedance at resonance. So that is the answer is 40 because the voltage at the inductor is also 40. So at resonance, the voltage at the inductor and at the capacitor is the same. So it's 40, 40. And that is the answer. Thank you. Let's look at this JAMB past question, Physics 2018, question number 26. If the fraction of atoms of a radioactive material left after 120 years is 1/64, what is the half-life of the material? A, 20 years, B, 10 years, C, 2 years, D, 24 years. Now, for us to be able to appreciate this question effectively, we need to first of all know what half-life is. And what is half-life? Now, half-life is the time required for a quantity to reduce to half of its initial value whenever there is radioactivity or in nuclear physics. So half-life, represented as T half, is the time required, that very time required for a quantity, for a given mass or quantity to reduce to half, of its initial, value. So that is half-life. The time, half-life, whenever you add half-life, we're talking about time. The time required for a quantity to reduce to half of its initial. So let's say the initial value is 20. That time it will take for it to become 10. From 20 gram to 10 gram. That time is known as the half-life. So now, how do we solve this given the number of years taken and the fraction of the atom remaining after these years? Now, for us to be able to effectively solve this, we need to note the movement from the first movement to half, which is the first movement. Now, if you're halving again, you're going to have 1 over 4, which is the second movement. If you're halving again, for the third movement, you're going to have 1 all over 8. And if you're halving again for the fourth movement, you're going to have 1 all over 16. And if you're halving again for the fifth movement, you're going to have 1 all over 32. And finally, you're having again for the sixth movement, you're going to have 1 all over 64. And 1 over 64 is actually what is given here. So how many movements got you to 1 over 64? You have 1, 2, 3, 4, 5, 6. 6 movements. So now, having that, you can see that half-life is equal to the total time all over the stages. That is the number of movements taken. And the total time is 120 years. All over number of stages is 6. 120 over 6 will give us 20. So the answer is 20 years. And that is how you solve these. Thank you. Welcome. Let's look at this JAMB past question, Physics 2018, question number 27. In the diagram above, which of the simple pendula will resonate with P when set into oscillation? A, U, B, T, C, R and T, D, Q and R. So this is the diagram showing P. You can see P, pendulum P, and pendulum T having the same length. You can see Q, you can see R, you can see S, you can see U. So, which of the simple pendula will resonate with P when set into oscillation? You can see that P and T are having the same length, so it's likely that T is the answer to the problem. And that makes option B the right answer to this problem. But before I arrived at this answer, it is pertinent that we know what resonance is whenever you're talking about simple pendulum. What is resonance when you're talking about simple pendulum? Resonance is that very condition when a body is made to vibrate, whenever you make a body to vibrate on its own natural frequency, then you're talking about frequency. You're talking about resonance. Whenever you make a body to vibrate on its own natural frequency by an external vibrating body, by another body that is vibrating, by an external vibrating body, then you have resonance. So from the figure of this pendulum, you can easily see that P is, when it's vibrating, it's going to impart resonance on T because both of them are having the same length. So it's likely that T will vibrate on its own natural frequency because of the vibration of P. So T is going to vibrate on its own natural frequency because of the vibration of P. And that is why B is the answer, because it's going to make T to resonate. P is going to make T to resonate. And that is the answer to the problem. Thank you. Let's look at this question number 28 for JAMB Past Questions Physics 2018. The time rate of loss of heat by a body is proportional to the A. Temperature of its surroundings, B. Temperature of the body, C. Difference in temperature between the body and its surroundings, D. Ratio of the temperature of the body to that of its surroundings. Now we need to understand what loss of heat is all about. So let's say we have this body and it's losing heat to the surrounding. Now, what will ensure that there is loss of heat from this body having temperature T1 to the surrounding having temperature T2 is what we call temperature gradient. Change in temperature, that is temperature gradient. That is difference between temperature of the body and that of the surrounding. That difference, that's what ensures loss of heat. And that makes C the right answer to these. It is not just the temperature of the body. If the temperature of the body is 1000 and the temperature of the surrounding is 1000, there will be no loss of heat because there is no temperature gradient. So if you have 1000 here and you have 1000 here, there will be no loss. Movement is only occurring when there is temperature gradient. If the temperature here is 10 and this one is 20, there will be movement. If it is 30 here and this one is 5, there will be movement. So there has to be difference in temperature. And that is what C is all about. It is not T2 over T1, which is what D is talking about. It is not the magnitude of the body temperature or the magnitude of the temperature of the surrounding. Because if the magnitude is so large but it's equal, then there will be no movement. So what actually causes loss of heat or movement of heat in and out of the body is the temperature difference. Once there is a temperature difference between T1 and T2, we have what we call temperature gradient, which allows for heat loss or even heat gain. So what we'll do this is what we call temperature gradient. And temperature gradient is actually the difference in temperature between the body and the surrounding. So you can say that this is T body and this is T surrounding. You can say that this is T body and this is T surrounding. Once there is difference between these two, once one could be 1000 and the other one could be 20, then you will talk about what we call temperature gradient. So C is the right answer to this. Thank you. Look at this JAMB Past Question Physics 2018, question number 29. A positively charged rod X is brought near an uncharged metal sphere Y and is then touched by a finger with X still in place. When when the finger is removed, the result is that Y has A, no charge and a zero potential, B, a positive charge and a zero potential, C, a negative charge and a positive potential, D, negative charge and a negative potential. So how do we go about solving this? Now, before we can be able to appreciate this question effectively, we need to understand what is called electrostatic induction or charging via electrostatic induction, or charging via physical touching. Now, the act of charging a neutral body by placing a charged body near it is known as electrostatic induction. So very, very importantly, we need to understand what electrostatic induction is so that we can be able to appreciate this question very well. And electrostatic induction is the act of charging a neutral body by placing a charged body near it. So when you charge a neutral body by placing a charged body near it, we'll call it electrostatic induction. Now, in this very instance, we are actually looking at you having a rod that is positively charged. This rod is positively charged and is brought near a metal sphere that is uncharged. This metal sphere is not charged, it's neutral. But then it is touched by a finger with this very X still in place. This is X, this is Y. So when the finger is now removed, when you now remove this, your finger, what do you expect to be on this very Y? On this very Y, you expect to have negative charge and a negative potential, and that makes D the right option for these. Thank you. Welcome. Let's look at this JAMB past question, Physics 2018, question number 30. Electrical appliances in homes are normally earthed so that A person touching the appliances is safe from electric shock. B, both the AC and DC sources can be used. C, the appliances are maintained at a higher PD, that is potential difference, than the earth. D, the appliances are maintained at a lower PD than the earth. Now, wherever you see AC simply means alternating current, and DC means direct current. So what is the answer to this very problem? Why do you earth in homes? Why do you earth? It is very clear and common sense that when we earth, we actually earth because we don't want anybody touching the appliances to have electric shock. We want them to be safe from electric shock. That is actually the reason why we do earthing. So whenever you hear the word earthing, earthing is done in order to prevent electric shock. So you do earthing in wiring in order to do what? Prevent electric shock. That is the sole essence of earthing, to prevent electric shock. And that makes option number A, a person touching the appliances is safe from electric shock, the right answer for this. You don't earth because both the AC and DC sources can be used. You don't earth because the appliances are maintained at higher potential difference than the earth. And you don't earth because the appliances are maintained at lower potential difference than the earth. The sole reason of earthing is so that a person touching the appliances is safe from electric shock. So earthing prevents electric shock. It's a special thing that you do in electrical wiring in order to prevent electric shock. And that makes A the answer to this problem. Thank you. Let's look at this JAMB past question for physics 2018, question number 31. The process whereby a liquid turns spontaneously into vapor is called A. Regelation, B. Evaporation, C. Boiling, D. Sublimation. So now, what is the process whereby a liquid turns spontaneously into vapor? Now, for us to get it into context, I'm going to be defining each of the following words that we have. Number one is regelation. What is regelation? Regelation is a phenomenon of melting under pressure. So when there is melting under pressure, we call it regelation. And not just melting, there is also refreezing. So when there is melting and refreezing under pressure, whenever the pressure is reduced. So regelation happens due to pressure, and it happens when pressure is reduced. There is what we call melting and refreezing. That is what regelation is. Then evaporation is actually the spontaneous turning. So if you have solid phase going straight into gaseous phase, then we'll call it sublimation. So from all this definition, we can see that B is the right answer for this. Evaporation is the process whereby a liquid turns spontaneously into vapor. Thank you. Let's look at these JAMB past questions, physics 2018, question number 32. Which of the following diagrams represent correctly an NPN transistor? Which of the following diagrams represent an NPN transistor? Is it A, as is drawn here, or B, C, or D? Now, for us to be able to appreciate this very well, we need to make a sketch of the diagram of NPN transistor. Now, the NPN transistor has the following diagram. You have this, and you have this, then you have this, then all of it encircled. Then here you have your A, B, and C. So this is the diagram of NPN transistor. So which of the following is very close to what we have here? This is actually E. So you can see that the major difference in all these is this movement going from C up, and that is what we have here. There's actually a movement here going from C up. We have B, we have E. So this makes D the answer. For this number C, we have the movement this side. For this, you have it this side, but going in opposite direction. Also here, you have it this side. So D is the right answer from the sketch that is done here. And that is why we picked option D, because this is the diagram of NPN transistor. Thank you. Hello, welcome. Let's look at these JAMB past questions. Physics 2018, question 33. The difference observed in solids, liquids, and gases